three-dimensional perspective. The once linear x and y axes transform into planes, specifically, the vertical plane, abbreviated as VP, and the horizontal plane, abbreviated as HP. The entire space between these two planes collectively constitutes the first quadrant, with subsequent spaces forming the second, third, and fourth quadrants. Consider a point located in the first quadrant. In such a scenario, the point is described as being above HP and in front of the VP. If the same point rests on the HP plane, it is designated as on HP and in front of the VP. Similarly, if the point rests on VP, it is termed as on or in VP and above HP. For a point in the fourth quadrant, it is positioned in front of VP and below HP, given its location in front of the vertical plane and below the horizontal plane. In the second quadrant, a point is represented as being above HP and behind VP, as it is situated behind the vertical plane. In the third quadrant, the point is described as behind VP and below HP, being positioned behind the vertical plane and below the horizontal plane. It's important to note that questions may not explicitly state the quadrant in which the point lies. Instead, they might specify the point's position as above or below HP and in front of or behind VP. In such cases, you must deduce the quadrant based on these indications. Additionally, questions may provide the distance of the point from the planes. For instance, if a point is stated to be 10 centimeters above HP and 5 centimeters in front of VP, it is located in the first quadrant. Conversely, if a point is 10 centimeters behind VP and 5 centimeters above HP, it resides in the second quadrant. This clarification should help address any uncertainties regarding the point's location. Next, we will explore the process of illustrating the front view and top view of a point in a 2D plane when positioned in different quadrants. Begin by drawing a horizontal line representing the XY axis. This line corresponds to the three-dimensional view. The vertical plane in the 3D view is depicted by the region above the XY line, while the horizontal plane is represented by the area below the XY line. This representation stems from the fact that, to portray views of an object situated in a quadrant, the horizontal plane undergoes a 90-degree clockwise rotation. Consequently, after the rotation, the horizontal plane takes on a new orientation. In this context, the vertical plane is the region above the XY line, and the horizontal plane is the area below the XY line. Consider a scenario where a point lies in the first quadrant at a certain distance from the XY plane. In this case, the point is said to be in front of VP and above HP. When we view the point from the front view, the point will be positioned above the XY line at a distance of y. Conversely, in the top view, the point will appear on the horizontal plane, at a distance of x from the XY line. Thus, the representation on the 2D plane for the first quadrant follows this configuration. Moving on to the second quadrant, where the point is positioned x distance away from the vertical plane and y distance from the horizontal plane. In this case, the point is said to be behind the VP and above the HP. In this scenario, the front view is projected onto the vertical plane, and the top view is projected onto the horizontal plane in the 3D view. To depict this in a 2D view, a 90-degree rotation of the horizontal plane is necessary. Upon doing so, both the vertical and horizontal planes overlap in the second quadrant. Consequently, the front view and top view of the point coincide above the XY line. Thus, when the point resides in the second quadrant, both views are represented above the XY line. Consider a point in the third quadrant. In other words, behind the VP and below the horizontal plane. Here, the front view is projected onto the VP, and the top view is projected onto the HP. Upon rotating the HP by 90 degrees, the top view aligns above the XY line, while the front view positions below the XY line. Hence, in the third quadrant, the projected views are represented accordingly. Finally, when a point lies in the fourth quadrant, in other words, in front of VP and below the HP, it is observed that the VP and HP overlap with each other. Consequently, in this case, both views are projected below the XY line. This outlines how the views of points are depicted in two-dimensional view across different quadrants. Certainly, let's explore these scenarios further with some illustrative questions. Consider the initial scenario. Point A is situated 50 mm above the horizontal plane, HP, and 60 mm in front of the vertical plane, VP. This means the point is in the first quadrant. To illustrate this, if we position the point above the HP and in front of the VP, the top view of the point will be below the XY line, while the front view will be above the XY line. Both views align vertically, with the top view 60 mm below the XY line and the front view 50 mm above the XY line. Now, let's examine another case. Suppose point A is 50 mm above the HP and 60 mm behind the VP. This means the point is in the second quadrant. In this configuration, placing the point above the HP and behind the VP results in both the top and front views being positioned above the XY line. Both views align vertically, and the front view of the point is 50 mm above the XY line, while the top view is 60 mm above the XY line. Moving on, point A is now 50 mm below the HP and 60 mm behind the VP. This means the point is in the third quadrant. If we position the point below the HP and behind the VP, the top view will be above the XY line, and the front view will be below the XY line. The vertical alignment is evident, with the top view 60 mm above the XY line and the front view 50 mm below the XY line. In a similar vein, consider another example. Suppose point A is now 50 mm below the HP and 60 mm in front of the VP. This means the point is in the fourth quadrant. Placing the point below the HP and in front of the VP results in the top view being below the XY line and the front view being positioned below the XY line as well. Both views align vertically, with the front view of the point 50 mm below the XY line and the top view 60 mm below the XY line.